Thanks for watching. If you enjoyed this video, please hit the subscribe button and ring the notification bell so you never miss an update. Leave a comment below to help grow the channel, and don't forget to smash the like button. Lecture 9, multiplying and dividing fractions. Now I know at the last lecture I said that the next lecture we would do would be adding and subtracting fractions, but I changed my mind. I wanted to present it a little bit differently. I think this will make more sense. Yeah, I think it would work better this way. So we're going to do multiplying and dividing fractions today. Next time we'll talk about adding and subtracting fractions. So where do we begin? Well, let's just take a look at a few things here. We recall from last time that we learned how to add fractions that have the same denominator. We call this a common denominator because they have it in common. So 1/3 plus 1/3, we know we just add the numerators and we keep the denominator the same, right? So this is 1 plus 1 over 3, which is, of course, 2/3. But remember what repeated addition is. Who remembers what we call repeated addition?
Escape counting.
Nope. Repeated addition, anybody? Multiplication? That's what multiplication is. It's just repeated addition. So what if instead of this we had 1/3 plus 1/3 plus 1/3, right? That's 1 plus 1 plus 1/3. That's equal to 3/3. Or 1/3 plus 1/3 plus 1/3 plus 1/3. That's 1 plus 1. Whoops, too many pluses. 1 plus 1 plus 1/3. That's 4/3. This is just multiplication, right? We're adding a third 2 times. That's the same thing as 1/3 times 2. 1/3 plus 1/3 plus 1/3. We're adding 1/3 3 times. So that's 1/3 times 3. Here we're doing it 4 times. So that's 1/3 times 4. So we see we kind of have a prescription here with this repeated addition of fractions, which we know how to do. Since it's repeated, that means it's the same fraction, right? Which means it has a common denominator. So we know how to add those. And so we have a prescription here for how to multiply a fraction times a whole number. A fraction times a whole number is just repeated addition. 1 plus 1 plus 1 plus 1. So let's try an example and see how this works for us. Let's take a fraction like 3/4 and multiply it times the whole number 5. Well, we know what it means. It means we're going to add 3/4 plus 3/4 plus 3/4 plus 3/4 plus 3/4. It's adding the same fraction 5 times. But from what we just saw, right, it looks like we can just simply multiply the numerator times the whole number and keep the denominator the same. So this is just 3 times 5 over 4, which of course is 15 over 4. Is that a proper or an improper fraction?
Improper.
Improper fraction, right? So we can write this as a mixed number. How many 4s go into 15? If it was 16, what is 16 divided by 4?
It's 4, guys.
16 divided by 4 is 4. So this is almost 4, which means it must be 3, right? What is 4 times 3?
12.
12. And what is 15 minus 12?
3.
Yeah. So this is 3 3/4. So in our final answers, we prefer improper fractions to be expressed as mixed numbers because it allows us to reason through it a little bit better. We see that number 3 3/4, we understand that perfectly. It's 3 almost 4, right? 15/4, you know, it's not so easy to visualize what that means exactly. Again, think of it as pizza deliveries. If I have to deliver 15/4 pizzas, you know, I don't really have a good feel for how many pizzas that is. But with a mixed number, I know exactly. It's almost 4 pizzas, right? Let's let you try one. I would like you to multiply the fraction 3/8 times the whole number 7. And for you at home, pause the video, calculate your answer, and then return when you've got it, and I'll show you the solution. What do we do? Well, for multiplying a fraction times a whole number, we take the numerator times the whole number, and we keep the denominator the same as before. So it's 3 times 7 over 8. Well, what is 3 times 7? 21 over 8. Is that a proper or an improper fraction? Improper, because the numerator is bigger than the denominator. So let's write it as a mixed number. How many 8s can we get into 21? Well, if we don't remember how to do this, we can divide 8 into 21. Yep, 2 will give us 16. And what is 21 minus 16?
5.
5. So we get a remainder of 5. But that means we can write the mixed number as 2 5/8. Remember, the fractional part of the mixed number will have the same denominator as the original improper fraction. Okay, don't flip it around. I've seen some of you put 8/5 before. Okay, your checkpoint is to make sure that the fraction here has the same denominator as the fraction here. Okay? Now, before, when I had 1/3 times 3, and we found that it was the same as 1 times 3 over 3, which is equal to 3/3. What's another way to write 3/3?
1.
It's 1, right? So if this is going to be equal to 1, what does that mean, right? Well, that means these 3's in the numerator, the 3 in the numerator and the 3 in the denominator must have to disappear somehow, right? And if you recall that a fraction is really nothing more than a division problem in disguise. It's the same thing as 3 divided by 3. And what is 3 divided by 3?
1.
It's 1. So I like to call this the key fraction rule. Key fraction rule. And what is that rule? Well, if I have A times B over A times C, this is just equal to B over C. So basically the idea is if you see a number in the numerator and in the denominator, you can basically cancel them out like this. You see that? And I'm left with just B over C, you see? Key fraction rule. And so we can use that when we're multiplying numbers to our advantage. Let me show you an example. So 5/16 times 8. Well, the way that I had prescribed it before, we would multiply the numerator, so we would do 5 times 8 over 16. And 5 times 8 is not so bad, but what if this was, 5/16 times 80 or 89 or something like that? It could be a much harder multiplication problem. So we want to try to minimize the work that we do, and so what we can do is we can observe here that 16, right, factors as 8 times 2. And if I were to simply rewrite this as 5 times 8 over 8 times 2, I can employ the key fraction rule to simplify this dramatically. I can see the 8 up in the numerator and the 8 in the denominator. These will cancel. And I'm left with just 5/2, which is a mixed number. Can anyone tell me what mixed number that is? That's a pretty easy one. 2 times 2 is 4, and 1 more makes 5, so that would be 2.5. Here we use the key fraction rule to avoid having to write the fraction. What is 8 times 5? Anybody?
40.
40? 40 over 16, which is not as easy to think about, and certainly not as easy to write as a mixed number as it would be to write 5/2 as a mixed number, right? They are the same, right? But I think it's just easier to work with it when you reduce these fractions as much as possible. And that's the technical term for it. It's called reducing the fraction. Let's let you try one. 3/8 times 2. So go ahead and pause the video, try that at home, and return when you've got your answer. What we're looking for is a factor of 2 in the denominator. If we have a factor of 2 in the denominator, we can cancel it with this factor of 2 that's in the numerator. 3 times 2 over... Can we write 8 as something times 2?
Yeah.
What can we write? What is that factorization?
4 times
4 times 2, right? 8 is just 4 times 2. These 2's will cancel, and I'm left with just the 3 in the numerator and the 4 in the denominator. So 3/8 times 2 is just 3/4. One of the varieties of problems that I'm going to give you on your homework is I will give you a fraction that may or may not be reduced. And your job is to reduce it if it's not reduced, and otherwise you would just leave it unchanged. So let's look at an example problem like that. Because sometimes when you get to the end of a calculation, it might be worthwhile to reduce the fraction to make it a little more palatable. So let's practice doing that real quick. But let me show you a technique, all right, behind this. And you can use either of the techniques that I show you here, but let's just go through it real quick. So if I wanted to simplify the fraction 12/18, excuse me, if I wanted to reduce the fraction 12/18, or to check if it's reduced, from a previous lecture, unfortunately, I don't remember what lecture this was. Was it lecture 5 or 6? No, this is lecture 9. I think it was lecture 6. We talked about the greatest common divisor, GCD. And so how did that work? We said, well, what is the greatest common divisor of a number like 12 and 18? And if you go back and you look at that lecture, you'll see that what we did is we created a factor tree. We looked through the factor tree here, right, and we put things in that it shares in common. So they both share a single 2 in common. So I'm going to put a 2 in this, okay? Do they share two 2's in common? No, they do not. So I'm not going to write another 2 in there. But they do have a 3 that they share. So I'm going to write a 3 in here. And so I get that 2 times 3 equals 6. And that is my greatest common divisor. And we can use that in reducing this fraction. Basically, if we divide the numerator and the denominator by 6, this fraction will be reduced. If the greatest common divisor turned out to be 1, that has a special term in math. It's called relatively prime. Okay, and it's not important that we know relatively prime, but if the greatest common divisor is 1, then the fraction is reduced. So if you want a surefire way to tell whether or not a fraction is in reduced terms, or in reduced form, I think would be a better way to say it, then see what the greatest common divisor is of its numerator and denominator. If it's 1, then it's reduced. So we can divide the numerator and the denominator by 6, and that will put this in reduced form. So what is 12 divided by 6?
2.
So we're going to say that 12 eighteenths is equal to 2. 12 divided by 6 is 2. What about 18 divided by 6?
3.
It's 3. So this says that 12 eighteenths in reduced form is 2/3. Now you can of course check this. Remember how we did this? Put a question mark over it and we checked it. What trick did we use to check a fraction? Cross multiplication. So this would be 3 times 12 equals question mark 2 times 18. What is 3 times 12? Anybody?
36.
36. And what is 2 times 18? Double 18?
36.
36. And 36 does equal 36. Now, another way to do this, instead of dividing the numerator and the denominator by the greatest common divisor, if you simply wrote the numerator and the denominator in terms of its prime factorization, you can use the key fraction rule to cancel out any, let's call it redundant parts, right? The things that are going to cancel. So we would have written 12. Let's write 12 over 18 equals, let's write the prime factorization for 12. That's 2 times 3. And then in the denominator, we'll write the prime factorization for 18, which is 2 times 3 times 3. This 2 cancels with this 2. This 2 stays because there's not another 2 in the denominator. But this 3 will cancel this 3. And we're left with just a 2 in the numerator and a single 3 in the denominator. So we get the same answer. Okay? So either way, either calculate the greatest common divisor directly, divide both the numerator and denominator by that, your fraction is reduced, or write the prime factorization of the numerator and the denominator, and then use the key fraction rule to cancel out the redundant terms. Let me give you one to try. Reduce 36/60ths. And just as a hint, this was one of the examples that we did for the greatest common divisor in lecture, what did I say, it was 7? Lecture 7. Feel free to reference that if you need to, or just do it from scratch here. So pause the video, do that, and come back when you're done. So I'm just going to, if you want to see how it's done, you can go back to lecture 7 and you will see that the greatest common divisor of 36 and 60 is 12. That's what we calculated in class before. And so if I divide the numerator and the denominator by 12, I can replace them with those quotients, and that will be the terms in my reduced fraction. So let's divide 12 into 36. Well, 12 times 2 is, double 12 please?
24.
24. What about 12 times 3?
36.
Yeah, 12 times 3 is 36, right? No remainder, so we can replace the 36 with 3. What about 60 divided by 12? How many 12s go into 60?
5.
Yeah, 12 times 5, right? Half of 120 is 60. If you go back to lecture, I think it was lecture 3, mental quick multiplication, then multiplying 12 times 5, you quickly see it's half of 120, which is 60. So this is a 5. Again, no remainder, so we can replace the denominator with this, 5. So 36/60ths reduced is 3/5. All right, so we've talked about multiplying fractions times whole numbers. What about division? Well, division's tricky. And I thought a lot about, like, how do we explain how to divide a fraction by a whole number? And we're going to have to take a little bit of a circuitous route. Let me just show you. So what do we know about division, right? Division is the opposite or the inverse of multiplication, right? So we know that A divided by a is 1. Yes?
Yes.
Yes. So if I were to ask, what is 1/3 divided by 1/3? Well, I don't know how to do this yet because I haven't explained to you how to divide a fraction by another fraction, let alone a fraction by a whole number, right? But I know that 1/3 divided by 1/3, just based on what the definition of division is, right, that this is equal to 1. Okay? Does that make sense? So let's use the insight that we got from the key fraction rule on how we might turn this into something that's going to equal 1. Well, we can see that if we had some way to get the 3's to cancel out, then that would certainly do the job.
Yeah.
And it turns out that's exactly right. So we rewrite 1/3 divided by 1/3 as 1/3 times 3/1. And now you see what's happening, right? We're going to have in the numerator 1 times 3, and in the denominator 3 times 1. The 3's cancel. We're left with just 1/1, which is just 1.
Yeah.
So this trick of taking the division problem and turning it into a multiplication problem, this is exactly how we divide
Yeah.
when it comes to fractions. And we call, so what is the relationship between 1/3 and 3/1? We have a name for it. We call it the reciprocal. So what is the reciprocal, all right, REC, of 3/4? What's the reciprocal of 3/4? Anybody?
4/3.
Yeah, 4/3. How about the reciprocal of 8/12?
12/8.
12/8. See how that works? We just switch the number in the numerator and the number in the denominator. We let them trade places. That's what a reciprocal is. If I wanted to take a fraction and divide it by a whole number, like 4, 4/9 divided by 4. What do? Well, we have to take the reciprocal of 4. Remember that 4, the whole number, is the same as the fraction 4/1, because 4 divided by 1 is 4. But we rewrite this as 4/9 times the reciprocal of 4. The reciprocal of 4 is 1/4. Now, this is nice because the key fraction rule, you can see what's going to happen. We're going to have 4 times 1 in the numerator. We're going to have 9 times 4 in the denominator. The 4's cancel, and I'm left with 1/9.
All right.
So 4/9 divided by 4, it kind of makes sense, doesn't it? Think about it. If I have 4 pizzas, and I divide that by 4, what is 4 pizzas divided by 4?
1.
It's 1 pizza. Not 1, but 1 pizza, you see? So if I have 4/9, and I divide it by 4, I'm left with 1/9, you see?
Yeah.
So you have to say it right for the analogy to work, okay? So 4 pizzas divided by 4 is 1 pizza. 4/9 divided by 4 is 1/9. Let me give you one to try. And I just want to point out that we now know not only how to divide by a whole number, but also how to divide by a fraction, okay, which is interesting. So let's try 3/4 divided by 9/16. Go ahead and pause the video and try that at home. Okay, so what's the first step? Should I rewrite this fraction problem? The division.
Yes, true.
I should rewrite this division problem as say it. You can say it. As a multiplication problem, right? So remember, don't change the first number, right? There's the number in front of the division symbol. That stays the same. This is where you're going to make a mistake. You're going to take the reciprocal of 3/4. That's not going to work, okay? You take the reciprocal of the number that follows the division sign. So 3/4 divided by 9/16 is the same as 3/4 times 16/9. Then you can kind of see we already have some nice cancellations that are going to take place here because we have 3. I'm going to rewrite 16 as 4 times 4. I'm going to rewrite 9 as 3 times 3. So over 4 times 3 times 3. You can see this 4 and this 4 cancel. This 3 and this 3 cancel. And what am I left with? I'm left with 4/3, which is, of course, an improper fraction. As a mixed number, that would be 1 1/3. In order to figure out how to divide fractions by whole numbers, we first discovered how to divide fractions by other fractions. And since we turn it into it seems like we already know how to multiply a fraction times another fraction. So what is the rule? Let me just kind of formally state it. If we're going to if we're going to multiply a fraction times another fraction, the rule is simple. Multiply the numerators and multiply the denominators. So, for example, 3/4 times 16 ninths, that's the one we just did. This is the same thing as 3/4 times 16 divided by 9. So I'm breaking this up into a multiplication by a whole number and a division by a whole number problem, you see? So what is 3/4 times 16? We know how to do that, right? That is just 3 times 4 times 4 over 4. This 4 cancels with this 4, and I'm left with just 12, because 3 times 4 is 12. So that's 12. But we still have to divide by 9. Now we just have a whole number divided by a whole number problem, and that's easy. That's the same thing as 12 divided by 9, or 12 ninths, which is 4 times 3 over 3 times 3. 3's cancel. I'm left with 4/3. And again, I get 4/3, or 1 1/3. So I'd like you to try 5/8 times 4/3 at home. Pause the video and come back when you've got it done. The rule, again, is simple. Numerator times numerator, denominator times denominator. 5 times 4 over 8 times 3. Now, it's at this point that you're going to want to think about it, and you're going to want to look for these important cancellations. And so you might say, well, 8 is 4 times 2. So I'm going to rewrite 8 as 4 times 2. That way, this 4 and this 4 cancel, and I'm left with a 5 in the numerator and a 2 times 3, or 6, in the denominator. And so we get 5, 6 as our answer. Is that an improper or a proper fraction?
Proper.
It's a proper fraction. So we're done, okay? Well, okay. I didn't ask the question, is it reduced? Right?
Yeah, looks used to me.
It is reduced because the greatest common divisor of 5 and 6 is 1. 5 is a prime, right? And 6 is not a multiple of that prime. So the greatest common divisor is 1. Therefore, this fraction is reduced. But you'll want to check your answers every time and see if they're reduced, okay? And the last thing I want to talk about, I want to point out a pitfall that's inevitably going to happen to one of you when going through this work. Let me just write a problem up here. Let's look at 4/9. Let me write that division symbol a little nicer. Divided by 3/4. Now, when you get in the habit of reducing fractions using the key fraction rule, you're going to be tempted to look at a problem like this and say, I've got a 4 in the denominator and a 4 in the numerator. Let me just cancel those out to make life a little easy before I start doing any work here. Don't do it, because it's not right. This is not equal to 1 over 3 divided by, I guess it would just be 1, right? That is not what it is. Right? You cannot cancel the 4 with this 4 and the 3 with one of the 3's, and 3 times 3 is 9. Does not work. You have to first rewrite the fraction, right, as a multiplication problem, right? Rewrite the division problem as a multiplication problem. 4/9 times the reciprocal of 3/4 is 4/3. Now you see the 4 and the 3 are exactly the wrong place to give you any kind of cancellation. This is just 4 times 4 over 9 times 3, which is just 16/27. Now, is 16/27 reduced? Is it a proper or improper fraction? Proper or improper?
Proper.
Proper fraction, because the numerator is smaller than the denominator. Is it reduced? Now, your instinct is probably never going to be, well, let me think what the greatest common divisor of 16 and 27 is. The most likely way you're going to approach this is you're going to say, do I see any factors in 27 that are common to the factors in 16 that might cancel? And there are no common factors in 16 and 27. So this is reduced. You don't believe me? Well, then let's just write its prime factorization. That's 2 times 2 times 2 times 2.
16 is...
I'm not done. 2 times 2 times 2 times 2. That's 16, yes? Yeah. And 27, right? How does that factor? Right? 27 is 3. There's no 2's into it because it's an odd number. Times 9, which is 3 times 3. And so that's 3 times 3 times 3. Yes?
Yes, I see.
There's nothing in the numerator that can cancel in the denominator. So this is reduced.
Yes.
Another way to say it is the greatest common divisor of 16 and 27 is 1, or that 16 and 27 are relatively prime. That's probably the way a mathematician would say it, I would guess. They'd say, well, 16 and 27 are relatively prime, so it's reduced. Okay?
Yes.
Yeah, but don't try to cancel stuff in the numerator and the denominator when you've written it as a division problem. Only look for that applications of the key fraction rule once you've written it as a multiplication problem. Now you can start looking for cancellations, but not here. No, bad. Okay? So put a circle around that big no. Don't do it. I think you know everything you need to know about multiplying and dividing fractions now. Okay? You can multiply and divide fractions by whole numbers, and you can multiply fractions by other fractions. Multiplying two fractions, multiply the numerators, multiply the denominators. Use the key fraction rule to look for cancellations that will allow you to reduce the fraction. When dividing a fraction, turn it into a multiplication problem, and what I just said before applies. That's it. So next time, I promise we will do addition and subtraction of fractions for the general case when there's not a common denominator. See you then.